In this short video, I will show how to modelize multi-story building in IgentForm software. Let's start from grid definition. By default, grid points are snap points. Now we can define the plate on the top of first level. After closing the contour, program automatically creates a solid. The next step is walls definition. Such elements like walls, beams and columns are always assigned to solid. They can be also defined before plate. In this case, they are assigned to fictive solid called floor outline. After plate definition, program automatically assigns all elements to appropriate solids. Here we use polyline mode to accelerate the definition if walls are in chain. Also, during definition, we can freely change snap modes. Here, mode with possibility to add vector to defined point is used. Now other internal walls will be added. In this case, polyline mode is switched off and walls are defined by 2 clicks. Wall thickness is taken from default settings. It can be changed at any time. Now beams will be added to our model. As for walls, we can use polyline mode. However, in this case, standard mode is used. After clicking beam option, in graphic menu we see near it an icon which shows current mode. Add, delete, select, change node position. These modes are easily available in context menu on 2D view. If we would like to change beam parameters, like for example cross-section, it is sufficient to switch on validate option. After definition, parameters can be changed. Also, in this example, it is shown how to change a wrong point. We can use undo option or choose change node position mode to correct data. In next step, we define columns. The procedure is the same as for walls and beams. We simply click in desired points and program automatically adjusts our input to snap points. Now we will try to define some openings in walls. In IgentForm, openings are part of section database. If we would like to modelize opening in a wall, it should exist in database. Openings can be typical like rectangular windows or door and also can have an advanced shape. When opening parameters are changed in database, these changes are automatically taken into account in model visualization, if these openings are used. Openings are added on 2D view. By default, insertion point is opening horizontal center, but the user has the possibility to change it by offset definition. When openings are defined, program automatically creates an elevation and assigns it to wall. This elevation is also a part of sections database and can be freely handled later. Now we pass to levels definition. A new level will be added and additionally the coordinate of first level will be changed. Program automatically adjusts all elements to new levels. The next step is plate definition on second level. Program has the possibility to display previous or next level to facilitate elements coordination. A different contour will be defined. In our example, thanks to it, balconies will be automatically defined. Later, they will be used to define live loads. To define walls on second level, we use copy modify option. To do it, we change current level in graphic menu, then we select a wall on 2D view and we use mention option from context menu. In dialog, we click on storey option and choose required level. If openings are defined in selected wall, they are automatically copied. If number of copies in this dialog is greater than 1, elements will be also copied to next stories, if they exist. Anytime we can verify our model on 3D view. It is also possible to display 3D view in main window and 2D view in small window. Then elements added on 2D view are directly visible on 3D view. We can define walls also in standard mode. Also here, display in previous level is very helpful during definition. As previously, polyline mode can be switched on or off depending on need. When any element is changed or added to section database, appropriate combo box controls are automatically updated in parameterization window and graphic menu. When, for example, during openings definition we change section, it automatically becomes a default section for next elements. A few openings have been added and our sample model is finished as far as geometry is concerned. We can verify it on 3D view, in this case by switching off the visibility of plates. Now we will try to add loads to the model. When we click Add option in Loads menu, a permanent load assigned to plate on first level is added by default. Load parameters can be easily changed. Here we assigned it also to plate on second level. We add next load on first level and we change its nature for live load. When we select level 1 in Stories branch and choose option Filter, only elements from this level are displayed on 3D view. Now possibility to divide solid contour for smaller plates will be shown. To do it, we select desired plate and we choose an option Divide Slab. By default, program proposes to use all internal walls in division and creates plates appropriately. Anytime we can change plate division by manual operations. Here we select a few walls and we switch off an option Take into account in plate division. Finally, we have a one main plate and 3 balconies. It is possible now to change plate thicknesses. For example, here we set the thickness of one of balcony plate for 10 cm. Now we can use this plate division to divide live load. To do it, we select live load case and we use option Divide into component loads. Loads assigned to all plates are automatically added to loads list. In this moment, it is possible to change desired load case value. Each load can be visualized on 3D view. When live loads are defined, it is possible to create live load schemas. They will be later used during combination generations. When scheme is added from graphic menu, we can choose which live loads will be present in this schema. The best way to add new schemas is to copy existing schema and then modify loads. During schema definition, loads in it are visualized on 3D view, so it helps in verification. In IgentForm, it is possible to generate automatically code combinations. Here we choose Eurocode from a few available codes, run generation and display table of all generated combinations. Let's assume that our model is completed. Now we can go to calculation phase. Calculations are performed according to load TakeDown method. Influence areas are displayed for all plates. After calculations, it is possible to display results for stories. Results are available for all single load cases and combinations. Then we can display results for the whole structure. Loads from stories are summarized. Finally, reactions on footings and continuous footings are shown. The last point in this video, it is a calculation node presentation. In dialog, we have the possibility to set different options like load cases selection, stories selection or objects selection. We select results for one load case, namely D1, and results for footing and continuous footings. It is possible to create a node in 3 formats, namely standard TXT file, RTF file and TXT file with tab as separator to import to spreadsheet. Finally, we save node in RTF format. Thank you very much for your attention and I invite you to see other IgentForm videos.